First of all, for this practice, we have to prepare the solution. It was important that the calculus of the solution were perfect for good results for all the practice, the part 1 and part 2. For the calculus, we could obtain the weight of each solution. It was very interesting how we prepare the solution because we practice what we have done before. What we did in this practice was to prove the influence of the concentration of the reactives on the reaction speed, and we could get the initial reaction speed and the partial of each element.
In this practice, we made different experiments with different reactants each time, and each time we changed the concentration of each reactant, and also on each experiment we changed the temperature. So we could calculate the constant speed of each type of experiment. The only thing we kept the same on each type of experiment was the temperature, so we could calculate the variation only depending on the concentration of the reaction.
In the first practice, we could do the experiment 1 and 2, and we could analyze the time and the reactions about with time, velocity, and movement. The first part of the practice was quite impressive because we could physically observe when the substance reached its chemical balance. It was necessary to agitate the mixture with a stirring device and an average of 5 to 15 minutes depending on the reaction, and we could observe the change of color. With the time obtained, we can get the velocity with the variables x and y, and the fact that our equilibrium constant was small means that the reaction reached the equilibrium of the reactant.
In conclusion, I note that the speed of a reaction can change very easily with any small change in the temperature or in the concentration of each reactant. But also I note that if you keep the same concentration of the reactants and the same temperature, the variation on each experiment is very small.
From the experiment part 1 and part 2, we can conclude that the temperature has to be more with the color and with the velocity of the reaction. If it is called the temperature, the slowly is the reaction. That it was very interesting that the change of color with the experiment third it was faster.
Finally, we weighed and timed the time that it takes to perform the reaction.
Once we got all the times from all the reactions on all the experiments, we could start getting the concentrations of the vitamin C and the peroxide. We got them from the number of moles and the volume of the flasks. Once we get the concentrations, we could use them in the chart and get the velocity of reaction, dividing the concentrations by the time that we got in the lab. Next, we can substitute the velocity of the reaction in the formula, get x and y. Once we get those, we were able to get the constant rate of reaction, which is expressed as K. In the case of when we used the flask at 12 Celsius degrees, K was equal to 0.003582. After that, we repeat the process with the different temperatures, 18 degrees and 25 degrees, to get the different constant rate of reactions. With all this data, we could make the chart in which we compare natural logarithm of K and one above temperature, as you can see in the screen. And finally, when we get the equation for the graph, we could get the total amount of energy that was in the reaction.
Our team conclude that the temperature directly affect the reaction time.
I think that this was a really nice practice at the lab because seeing the change in the color of the flask was kind of fun, but all the calculations that we had to do were kind of difficult, and well, it was important to see how the temperature affects the time in the reaction, but I think it was really difficult.